series, we have been looking at the basics and fundamentals of engineering graphics and engineering drawing. So, in that in the previous video, we saw position of points. In this video, we'll continue further and we'll explain position of lines. So, position of lines is a successor or the next part or next step in the engineering graphics or engineering drawing. So, what is a line? Line is nothing but it is a straight path that connects two points. A straight line is the shortest distance between any 2 points in space. So we know that it is connecting 2 points. The shortest distance uh, is a line, and then it represents some point that is in a fixed space, but it should be a linear path. And line should consist of at least 2 points or more. So the projection, each points are projected should projected, right? So when you project each point further, it leads to projection of lines. So thus, based on the projection of points, the projection of lines should be drawn based on that, and it will be the extension of the line. So to represent that, it will have like the vertical plane and the horizontal plane. These are the reference planes. So in projection of line, uh, what we'll see is we'll see the length, its position, and uh, its position in space, and also with respect to the horizontal plane and vertical plane. If it is inclined with respect to horizontal plane or vertical plane or both. So these are things that have to be considered before drawing the front view and top view with with the reference plane as the uh, I mean the reference with which the views are drawn. So what are simple cases of a line? So line can be anywhere in the space, right? With respect to horizontal plane and vertical plane. So there are cases where, um, five cases with which we can draw a line, or a line can be situated and thus can be projected based on that. The first one is line parallel to both HP and VP. So the line is parallel to both horizontal plane and vertical plane. So it will be parallel to both. The next one is a vertical line. That is, line is perpendicular to horizontal plane but parallel to vertical plane only. So let's say like we have vertical plane. If the line is this way, so it is parallel to the vertical line, but it is perpendicular to the horizontal plane, right? So that sort of lines will be coming under the second type. Third one is line inclined to HP and parallel to VP. So line is inclined to HP, but it is parallel to VP. So the line will be making an angle with a horizontal plane, but considered with respect to vertical plane, it does not make any angle. So it is parallel to the vertical plane only. So vice versa will be line is inclined to vertical plane, but parallel to horizontal plane. And the last option is line is inclined to both horizontal and vertical plane only. We'll see how we'll see how it is what is the explanation for these simple cases of line and how it should be projected. So these are some of the key points that you have to remember: the true length, the actual length of the line. Plan length is the top view length. So we have to first know something called top view's other name is plan, and front view's other name is elevation. Then we have side view, the length which we can see in the side view, apparent length. And then we have inclination with HP and inclination with VP. Inclination with HP is marked by a theta, and inclination with VP is marked with a phi. And similarly, apparent angle with HP is alpha, apparent angle with VP is beta, horizontal trace, vertical trace, and all of these are used to find the extension of the line. So line is parallel to both planes, the first one. So you see this line, the line AB, A, B. So the point A and point B. These two are here. So what you can see is when these two are connected, the line is parallel. This line is parallel to the horizontal plane, and parallel to the vertical plane also. So when you project A, so we can project it with respect to the horizontal plane and also with respect to the vertical plane. So point A is above HP and in front of VP. So it can also be on the other side also, just for you to understand a bit easier. And point B is above HP and in front of VP. So this can be represented. So since this is in the, this is in 3D, we have to represent it in 2D paper, right? So what we do is we flip this horizontal plane this way. So we get a straight one, and we can represent it on a paper. We have the reference line XY, and A B is here, and A dash B dash. So top view A B is here, and front view A dash B dash is represented on the vertical plane. So from this you can understand that a line is horizontal, it is parallel to HP or VP when its TL is visible in TV or FE respectively. So both front view and top view will parallel to XY, and both will show that the top line. If a line is parallel to both HP and VP, it must be perpendicular to the PP. So PP is the profile plane. It will be perpendicular to the profile plane. Therefore, point A and point B will coincide in the side view of the line. Hence, the left hand side view is a point view. So when you look at left or right, it will be just a point, right? So since it is a two-dimensional line, so it will be point view. So here's a example problem where line AB is 50 long, is placed in first quadrant. So 50 long is here, and it is parallel to both HP and VP. So it is 20 above HP. From here it is 20 and 30 in front of it. From here it is 30 So how do you draw? So if it is 20 above HP, we draw it 20 above HP, and it is 30 in front of. In front of is always drawn below the reference line. So we have 30 here. Okay. So from this we can draw a line that is like 50 centimeter and 50 long. So make these two parallel to each other, and these should be at the exact point. So just draw a line from here and make sure that these two are aligned together. So the next one is line perpendicular to either of the reference planes. So if it is perpendicular to vertical plane or it is perpendicular to the horizontal plane. So if it is this way, it is perpendicular to the horizontal plane. You can see here there is AB. AB is perpendicular to the horizontal plane and but parallel to the vertical plane. So you can see this A dash and B dash. You can see the front view, but top view is will be a point AB. Is it clear? So when we try to represent that here in the orthographic pattern, you can see that we have the XY line, the reference line. Above that we have the front view, that is A dash B dash. So we can see this here, right? This part we can see. So we put it this way. From the front view, it will be represented as is. But when you look at it from top, what will we see? We'll see it as a dot. It will look like a dot. So both A and B fall on the same line, right? So we call it AB. Is that clear? So since it is uh, in front of VP, it will be mentioned below the reference line. Is that clear? So we'll do the next rest of the part in the next video.